Hello, I'm Jim Flanagan and welcome to my virtual studio. This is the first in a series of lessons entitled Math, What's the Use? I'm hoping they'll be used by math teachers to make class a little more interesting and by anyone curious about the practical applications of math. Our first lesson involves probability. Please enjoy. When should I buy a lottery ticket? Is it always a good bet or is it always a bad bet? In order to answer that, I'd like to take you to a rather unique casino. We walk up to the first table. The game is simple. You put $1 down on any number from 1 to 6. The woman running the table will roll one die. If the number showing up on the top of the die is the number you chose, you win $1. If any other numbers come up, you lose $1. Would you want to play? Probably not. But why not? Because it looks like you will lose more often than you'll win. We can use an Excel spreadsheet and make 3 columns. The first column keeps track of how many games have been played. The second column is random numbers that could come up on the die. And the third column is keeping track of the amount of money you would have if you start with $100. You can see just playing the game 25 times, you're losing. So let's try our luck at the next table. It's the same game, but at this table you get paid $5 every time you win and pay $1 every time you lose. Does that sound better? Using our Excel spreadsheet again, you can see after playing 25 games, we're doing better than we did at table 1, but we don't seem to be getting too far ahead. So now let's go to the third table. Turns out to be the same game again, only here you pay $1 when you lose and you get $1,000 when your number comes up. You want to play now? Sure you do. But why? Because you're pretty confident you'll come out ahead. Let's revisit table 1. The probability of you winning is 1 in 6, and we can say the odds are 5 to 1. The money odds are 1 to 1 because you get paid $1 when you win and pay $1 when you lose. At table 2, the chances of winning are still 5 to 1, but the money odds are also 5 to 1. That's an even game. It's fair, but not very exciting. If you sat and played at this table for hours, you probably wouldn't lose much, but you probably wouldn't win much either. Finally, let's revisit table 3. The odds of winning are 5 to 1, but the money odds are 1,000 to 1. It seems we have to balance the odds against the pot. And now we can talk about the lottery. I'm going to use the New York State Lottery Mega Millions for my example, but you can apply this to any lottery game. In Mega Millions, you bet $2 per game. The game has 2 parts. You need to choose 5 numbers from 1 to 70 and 1 number from 1 to 25. If the state draws the same numbers as you win. But just as in our earlier dice games, how much you win makes a big difference. So in Mega Millions, what are the odds of winning? Well, there's 2 terms you should know: permutations and combinations. Using math notation, the permutation of 3 letters taken 3 at a time is 6. And you can see here the list of permutations of the letters A, B, and C. You can see that in permutations, order makes a difference. But in the lottery, it doesn't matter what order the numbers are chosen. 7, 21, 42 is the same as 42, 7, 21, which is the same as 21, 42, 7. That makes a combination. The combination of 6 things, say the letters A through F, taken 2 at a time would be 15. And this would be the complete list of those combinations. In Mega Millions, there are really 2 games you have to win. In part 1, the number of combinations of 70 things taken 5 at a time is 12,103,014. But you also have to win part 2. Here, you're only picking 1 number out of 25, so the odds of you getting the right number is 1 in 25. The probability of you winning both parts is found by multiplying the probabilities together. By the way, a shortcut would be to look at the back of the ticket where you'll find the odds list, but it's more fun to calculate it ourselves, don't you think? So the odds of you winning one game of Mega Millions is 302,575,349 to 1. Now let's imagine the jackpot's up to $3 million. That would give you money odds of 3 million to 2. 3 million you win and $2 you had to pay to play the game. Reducing that fraction makes it 150 million to 1. Just like our imaginary casino, if the money odds are lower than the odds of winning, then we shouldn't play. In Mega Millions, the pot would have to get to over 605 million or double the odds of winning just to be a fair game. Now you may think it's only $2, and that's fine, it's your money. But if you're the kind of person who plays the lottery every day, well, it's something to consider. Here endeth the lesson. Thanks for listening.